Good morning, students. Today we're going to do operations with fractions. So at the top of my notes, I wrote a quick little outline for you to write down so that you can remember how to add, subtract, multiply, and divide fractions. So when you're adding and subtracting fractions, you want to make sure the denominators are the same. If they're not the same, then you have to get them the same by finding the least common multiple. When you multiply fractions, you're going to multiply straight across. So the numerator gets multiplied to the numerator and the denominator gets multiplied to the denominator. And when you're dividing, you multiply by the reciprocal of the denominator. We're going to do several examples of each of these, but I wanted you to have this written down in your notebooks first so that you can go back and read through it when you get the chance or when you're working on your homework to remember how to do it. So let's start first by just reducing fractions. So to reduce a fraction, you want to break it into its prime factorization. And we do that by using a factor ladder. So I'll take the number 15 and I'll do it on my scrap paper. So I write the number 15 down and I want to divide it by the smallest prime number I can think of. So I know that 15 is divisible by 3, so I put a 3 out here. Then 3 goes into 15 5 times, and then you draw another one. This is why it's called a ladder. And then the smallest prime number that goes into 5 is 5. 5 goes into 5 one time, and I'm done because I only have one. So the prime factorization of 15 would be 3 times 5. And then I want to do the same thing with 20. So I'm going to take my 20. The smallest prime number that I can come up with that goes into 20 is 2. And 2 goes into 20 10 times. Smallest prime number that goes into 10 is 2. 2 goes into 10 5 times. Smallest prime number that goes into 5 is 5, and 5 goes into 5 one time. Once you get that one, you're done. So my prime factorization is 2 times 2 times 5 for 20. And then you want to cancel like terms. So I have a 5 in the numerator, and I have a 5 in the denominator. Those 5s will cancel. Nothing else will. So my reduced fraction is 3 over 4. So that would be my answer for the reduction. We're going to do it again with 30 and 400. So again, I'm going to take my 30. Smallest prime number that goes into 30 that I can come up with is 2. 2 goes into 30 15 times. Smallest prime number that goes into 15, 3. 3 goes into 15 5 times. And then smallest prime number that goes into 5 would be 5. 5 goes into 5 one time. So my prime factorization for 30 is 2 times 3 times 5. And again, this is called a factor ladder. Then I'm going to take my 400, and I'm making a factor ladder. Prime number that goes into 400, well, it's even, so even numbers are always divisible by 2. 2 goes into 400 200 times. 2 again goes into 200. 2 goes into 100. 2 goes into 50. And then 5 and 5. So my prime factorization for 400 is 2 times 2 times 2 times 2 times 5 times 5. Make sure I have it 1, 2, 3, 4 2s and 2 5s. All right, so now I'm looking for a numerator, a factor in the numerator, and a factor in the denominator that will cancel. I can cancel this 2, and I can cancel one of the 5s. So left in my numerator is 3. Left in my denominator is 2 times 2 times 2 times 5. Well, 2 times 2 is 4, times 2 is 8, times 2 is 5 is 40. So I have 3 over 40. Again, you can slow down the video if you need to. Our last example is 20 over 48. You should try it without me and see if you get my same answer. So I'm going to go ahead and do it. So I have 20. Again, it's even, so I know it's divisible by 2. Even again, divisible by 2. And that's divisible by 5. And I get the 1, so I know I'm done. So this is 2 times 2 times 5. And then I've got to do 48. So again, my factor ladder. 48 is even, so I'm going to divide it by 2. It's 24. Again, that's even. It's divisible by 2. That's 12. Again, it's even, divisible by 2. is 6. Again, it's even. Divisible by 2 is 3. And then the only thing goes into 3 is 3. Then I get my 1. So 3, 1, 2, 3, 4 2s and a 3. So 1, 2, 3, 4 2s and a 3. So that's its prime factorization. So, sorry, children. And so I can cancel a 2 from the numerator and denominator, cancel another 2 from the numerator and denominator. And in the numerator, I'm left with a 5. And in my denominator, I have 2 times 2, which is 4, times 3, which is 12. So my reduced fraction is 5/12. Okay, now we're going to move on to finding the sum. So remember up in our notes, to find the sum to add, denominators must be the same. So that's the first thing you're going to look for is, are my denominators the same? And in this example, they are. If they are the same, then you're just going to add the numerators and keep your denominator. So the answer to this would be 4/3. Again, if the denominators are the same, you carry the denominator and add the numerators. So my answer would be 4/3. And I could only do it that easy because these denominators were the same. In our next example, the denominators, let me move it up, sorry. In our next example, the denominators are not the same. So I'm going to have to do some manipulation to get them the same. So in order to do that, you want to find the least common multiple. So go back to my scrap paper. So the multiples of 3 are 3, 6, 9, 12. So that's 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5 is 15, 3 times 6 is 18, and etc. The multiples of 4 are 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20. And I'm going to stop. And you're trying to find the least one they have in common. And if hopefully you saw it, it was right here. The least common multiple is 12. So that is going to be my denominator. So I'm going to write 12 and 12. So now you have to say to yourself, what do I multiply this 3 by to get 12? So to go from 3 to 12, you have to multiply by 4. So I've got to, whatever I do to the denominator, I also have to do to the numerator. So 3 times 4 is 12, and 2 times 4 is 8. So this will be an 8. And then I go to my next fraction. How do I go from 4 to 12? I need to multiply by 3. So again, whatever I do to the denominator, I have to do to the numerator. So 4 times 3 is 12, and 1 times 3 is 3. Now that my denominators are the same, I see that they're the same, I carry my denominator and I add my numerators. 8 plus 3 is 11. So my answer is 11/12. Again, we're going to do one more example, and if I were you, I'd try to do this without me first and then turn the video back on to check your answer. So I have a 9 and an 8. So same thing, I'm going to take my 9 and write down my multiples. So 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 54, 9 times 7 is 63, 9 times 8 is 72. Hopefully that's far enough. And now let's try 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40, 8 times 6 is 48, 8 times 7 is 56, 8 times 8 is 64, 8 times 9 is 72. So, have you found my least common multiple? I think you have. It's that 72. So, good practice to remember your multiplication too. So, my common denominator is 72. So, I'm going to come back over here and write 72, 72. And then remember, I have to multiply, whatever I multiply by 9 to get to 72, I have to do the numerator and denominator. So it was 9 times 8, so I'm going to multiply by 8, multiply by 8. 9 times 8 is 72, 2 times 8 is 16. Same thing with the 3/8. 8 times what gives me 72? The answer was 9 times 9 times 9. 8 times 9 is 72. 3 times 9 is 27. Once the denominators are the same, you carry that denominator and then you add the numerator, and 16 plus 27 is 43. If you've done it correctly and have used the least common multiple, you will not have to reduce your ending fraction. It'll already be in reduced form, but be careful if you haven't chose least common multiple. Sometimes you need to reduce your answer. Okay, now to find the difference, it's the same thing that we did for finding the sum, except we're subtracting the numerators instead of adding the numerators once we get that common denominator. So again, the first thing I want to get is a common denominator. So we have 4 and 3. We already did it up here, so I know my least common multiple of 4 and 3 is 12. So I'm going to go ahead and write 12 and 12. To get from a 4 to a 12, I multiply by 3. And whatever I do to the denominator, I have to do to the numerator. So this is going to be 3 twelfths. And then to get from 3 to 12, I multiply by 4. So again, times 4 times 4. 1 times 4 is 4, so this is going to be 4. And then I have 3 twelfths minus 4 twelfths. So I know it's going to be 12. I carry that denominator. And 3 take away 4 is negative 1. Remember, we did that a few lessons back. If it's difference, you take the difference of the numbers. The difference of 3 and 4 is 1, and take the sign of the larger number being 4, and it's negative. For our next example, our denominators are 5 and 2. That's a new one, so I'm going to take my paper and write down my factors of my multiples of 5 and 2. So the multiples of 5 are 5, 10, 15, 20, 25, etc. The multiples of 2 are 2, 4, 6, 8, 10, 12, etc. And the least one that they have in common is 10. So my least common multiple is 10. So 10 minus 10. To get from 5 to 10, I'm going to multiply by 2. So 2 times 2 is 4, so I have 4 tenths. And then to get from 2 to 10, I multiply by 5 times 5 times 5. 2 times 5 is 10, and 1 times 5 is 5. So now that my denominators are the same, I carry the denominator and I subtract the numerator. So 4 take away 5 is again negative 1. And then on our last example, I encourage you to do this without watching the video at first, to try it yourself, and then turn the video back on to check your answer. So I'm going to start with my multiples of 20. The multiples of 20 are 20, 40, 60, 80, etc. The multiples of 4 are 4, 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And I can stop because I've already got my least common multiple. It's 20. So I'm going to make both of my denominators 20. To get from 20 to 20, I just multiply by 1. So that's not going to change anything because 3 times 1 is 3. To get from 4 to 20, I have to multiply by 5. So remember, whatever you do to the denominator, you have to do to the numerator to keep them equivalent. So 1 times 5 is 5. Once the denominators are the same, I carry the denominator, and 3 take away 5 is negative 2. Now, if you notice it all, I can reduce this fraction, which you should. It's the first one. Oh, sorry, I didn't box these answers. This is the first answer that I'm needed to reduce it. So the numerator, it's already in its prime factorization. 2 can't be broken down. It's 2. I believe we already did 20, but I'll do it again. So if I take my 20, I know 2 goes into it 10 times. 2 goes into that 5 times. 5 goes into that 1 time. So I have 2 times 2 times 5. Again, I can cancel that 2 from the numerator and the denominator, and my answer would be, when everything cancels, it's not 0. I have a 1 understood there, so I have a negative 1 divided by 10, and that would be my answer. Now we're going to move on to multiplication of fractions. And if you again remember from our notes, to multiply, we multiply straight across. In other words, numerator to numerator and denominator to denominator. So in multiplication, I'm going to multiply my numerator. So 1 times 8 is 8, and 4 times 3 is 12. Easy enough. And then once you get there, you want to break them down into their prime factorization. So again, I'm going to take the 8 and do the factor ladder. So 2, 4, 2, 2, 2, 1. So 8 is 2 times 2 times 2. And 12 is divisible by 2 6 times, divisible by 2 3 times, divisible by 3 1 time. Again, you stop when you get that 1. So I have 2 times 2 times 3. I can cancel 2 2's from each, and I'm left with 2 divided by 3. Okay, let's try another one. So we have 3 times 12 over 4 times 20. 3/4 times 12 over 20. So 3 times 12 is 36, and 4 times 20 is 80. Now I'm going to do the factor ladder for each. So 36 is 2, 18, 2, 9, 3, 3, 3, 1. So 36 is 2 times 2 times 3 times 3. And then 80 is 2, 2, 2, 2, and then 5. So this is 2 times 2 times 2 times 2 times 5. And then I see I can cancel 2 2's. And in the numerator, I'm left with 9. And then denominator, I'm left with 2 times 2, which is 4, times 5, which is 20. Again, on our last example, I'm going to encourage you to do it without watching and then turn the video on to check. So 5 times 20 is 100. 16 times 30 is, you might need to work it out on another piece of paper, but it's 480. And then I'm going to do my prime factorization. So 100 is 2, 2, 5, and 5. So 2 times 2 times 5 times 5. And then 480, again, it's even, so I know it's divisible by 2. Again, it's still even, so divisible by 2. Still even because it's got that 0 on it, divisible by 2. Still even. Still even. And then 3, I'm running out of room, and then 5. So I have 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5 2's, and then a 3 and a 5. So I can cancel 2, 2, and a 5. So left in my numerator is 5. In my denominator, I have 2 times 2, which is 4, times 2, which is 8, times 3, which is 24. Hopefully by the end of this, you're really getting good at remembering your multiples and your factors. Okay, last examples. We're moving on to division. And remember, again, back to my notes. When we divide fractions, we're going to multiply by the reciprocal of the denominator. So this can be written as 7/8 divided by 3/4. So this 3/4 is my denominator. And the reciprocal, so it says I take my numerator and leave my numerator, and then I multiply by the reciprocal of the denominator. So the reciprocal of 3/4 is 4/3. So in other words, we change division into multiplication by multiplying by the reciprocal of the denominator. And then we just repeat what we did in the previous part of this assignment. So when you're multiplying fractions, you multiply numerator to numerator. So 7 times 4 is 28. Multiply denominator to denominator. 8 times 3 is 24. Then do the prime factors of both. So 28 is divisible by 2. 14 times divisible by 2. 7 times 7, 1. So it's 2 times 2 times 7. 24 is divisible by 2, 12, divisible by 2, 6, divisible by 2, 3, and then 3. So it's 2 times 2 times 2 times 3. Cancel a 2, cancel a 2, and that gives me 7 over 2 times 3, which is 6. So I end up with 7/6. Just a couple more students. So again, this is 4 over 15. I change the division into multiplication by multiplying by the reciprocal. So the reciprocal of 7/12 is 12 over 7. And then once I have multiplication, I multiply my numerators, multiply my denominators. 15 times 7 is 35. 35, carry the 3, so 105. And then I do a factor ladder for both. So 48 is 2, 24, 2, 12, 2, 6, 2, 3, 3, 1. It's a 3. So I have 2 times 2 times 2 times 2 times 3. And then 105, remember anything that ends in a 5 is divisible by 5. So that's 21, and then 3, and then 7. So 5 times 3 times 7. So the only number that will cancel are the 3's. So I have 2 times 2, which is 4, times 2 is 8, times 2 is 16. So I have 16 over 5 times 7 is 35. So my answer is 16 over 35. Last example, again, I encourage you to try it without me and then turn the video on to check it. So again, I take the 15 over 16 and then I multiply by the reciprocal of 10/4, which is 4 over 10. And then when I'm multiplying numerators, I multiply straight across. So 15 times 4 is 60. 16 times 10 is 160. And again, I'm going to do my factor ladders for both. So I'm going to go to my papers in my room. So here's 60. So 2 goes into that 30 times, 2 goes into that 15 times, and then 3, and then 5. So 2 times 2, 2 times 2 times 3 times 5. And then 160, 2 goes into that 80, 2 goes into that 40, 2 goes into that 20, 2 goes into that 10, 2 goes into that 5. So it's 1, 2, 3, 4, 5 2's and a 5. 1, 2, 3, 4, 5 2's and a 5. So really quick, you can see that the 5's cancel, a pair of 2's cancel. Left in my numerator is a 3, and my denominator I have 2 times 2, which is 4, times 2 is 8, so 3/8. Well, that is it, boys and girls. I hope that helps you get through your assignment. Again, you can watch the video as many times as needed, and can't wait to see you soon. Have a great day. Bye.